Today, the pattern hunting will begin. How much you observe pattern becomes, way more important. So first, we will immediately begin with the pattern observation. A few questions. Now, what is this? 7 power 7777. So let's look at a question which deals with last two digits of this product. 101, 102, 103, 197, 198. Note on last two digits. A few pointers. Hello everyone, welcome to this video. In this video, we are going to do something very interesting. Okay, this is not going to be a theoretical or anything like that. Today, the pattern hunting will begin, right? As I said there. So in IOQM, more than the theoretical knowledge, what is important is pattern observation. How much you observe pattern becomes, way more important than how much knowledge you have of the number theory or algebra or any subject. So I highly suggest you all that whatever we are going to do today in this session, I want you to do it on your own, at your own pace. Maybe I'll be a little bit faster or slower, I don't know. So take your time and spend time observing patterns in numbers. Right? I want you to look at how numbers work. It is a very fascinating thing. I used to do this when I was a kid. And on my own, I had actually discovered these things, but this is there in many books. So for today's lecture, actually, I'm going to refer the problems which I have stated here and everything. I'm referring the IOQM preparation book by Vedantu, right? I'm just letting you know so that you can also refer whenever you need. Okay, so unit digits and more, right? So first, we will immediately begin with the pattern observation of numbers like 2n, 2 power n, and so on and so forth. So we'll do that for every number. So what is 2 power n? So for n1, it starts with 2, n1, 2 power 1, 2, 4, 8, 16. We are mainly interested in patterns of unit digits. Right? So let's only look at that. Now 6 into 2, 32. So we have 32. Whatever it be, it will be 4, something 4, something 8, something 6. So it's going to repeat. So do you see the pattern? 2, 4, 8, 6. 2, 4, 8, 6, and so on. So the 2, 4, 8, 6 is repeating in the powers of 2. Okay, let's do for 3. So we have 3. I'll have a 9. And then I'll have 27. I'm only writing the unit digit. Okay. Now 7 3s are 21. Now the moment there is 1, of course it will repeat. It will go to 2. So let me just write it a bit above so that I'll have space for the numbers in the bottom. It is 3, 9, 7, 1, 3, 9, 7, 1, and so on. Right? This pattern is going to repeat. Now in the 4 is 16. So 16. Okay, let me write 27, 81, 243, and so on and so forth. So it's not important. The other number is going to be 64. It's going to be something 6, something 4, something 6. So do you see the pattern here? 4, 6, 4, 6, 4, 6 is repeating. And for 5, it is quite obvious because it will only end with 5. Right? 5, it's easy. Okay. For 6 is also easy. It's going to be 6, 6, 6, 6, 6. So 6, 36. Whatever the next number is, 6, 216, right? 6, 36, 216, 6. So it's going to repeat. 6 will be the last digit whenever the power of 6 is taken. And okay, 7, it's 7, 49, 343. Something, whatever you multiply now, 3 multiplied with 7 will be 21. So it will end with 1. So 7, 9, 3, 1. By now, we should have figured it out that the powers are repeating in a cycle of 4 as a set of 4 at most, right? The maximum different numbers which we have is 4, and after that it's repeating. It is 7, 9, 3, 1. Right? Maximum it's 4, otherwise it's also just 0, just 6, right? Of course, we didn't include 0 and 1 because 0 if the last digit was 0, if you take power n anything, it will be 0. If the last digit was 1, again, if you take any power, it will be 1. Okay, so nothing to worry about that. 8 power n, so 8, and then 8 8 is 64, 4 8s are 32, 2 8s are 16, 6 8s are 48. So again 8, 4, 2, 6, it's repeating, right? So you see that these 4 numbers are going to repeat. So if you, I'm really hoping that you are sitting along with your pen and paper. You're not sitting idly watching a video like this. This is an educational video, come on. So I hope you're taking the notes that this, this is the pattern. Because we'll do something with this right away. 9 power n, it's 9. 9 9s are 81, and the moment there is 1, it's going to be 9 again. So for 9, it is only 2. So for which numbers is it repeating only once? So if you take unit digit of 5 power n, unit digit of 6 power n, always same. But if you take unit digit of for which is it repeating in set of 2, it could be 9, or it could be set of 2, so 4. 9 and 4 are repeating in set of 2, right? Unit digit of 4, unit digit of 9 repeats in 2. And the unit digits of the rest of the numbers, right? 2, 3, 4, 5, 6, 7, 8. Powers of these repeats in 4 numbers. Okay, that is the pattern. So it repeats in 4 numbers. So how do I write it down? Can I formulate it? I think we can formulate it, right? So let me think about it. You also think about it. That you have, can I find unit digit of 2 power 34 into 3 power 41? Yeah, is that possible? Now this should be very easy, considering that, can I find the unit digit of, this should be unit digit of 2 power 34 into unit digit of 3 power 41. Right, I mean, it looks like a big formula, but it's nothing. Simply, I'm taking the unit digit of this, unit digit of this, and I'm multiplying them, right? It's nothing. So, so when I take the product, now what is this? What is the unit digit of 2 power 34, right? So 2, for 2 it repeats like 2, 4, 6, 8. Now 8 is when the power is 4. Let me write the powers, 1, 2, 3, 4, 5, 6, 7, 8. If you take 2, 4, 6, 8. Now whenever the power is of a multiple of 4, the power is going to be 8. So you must note this, unit digit of 2 power n. I can divide it as if the power is multiple of 4, multiple of 4 plus 1, multiple of 4 plus 2, or multiple of 4 plus 3. We saw that when divided by 4, there will be 4 reminders. For each remainder, there is going to be a unique power. So if n is of the form 4k plus 1, then the power is always 2. If n is of the form 4k plus 2, then it is 4. 4k plus 3, it is 6. 4k itself is 8. This is the pattern. Now, where does 34 lie? Where does 34 lie? The unit digit of, so first of all, let's look at what is 34. 34 is 32 plus 2. 32 is 4 into 8 plus 2. So it is also form 4k plus 2. This. So unit digit of 2 power 34 will be 2. Oh, I'm sorry, 4. Is that understood? Because 34 is of the form 4k plus 2, right? Similarly, in fact, almost exactly, you can find unit digit of 41. Now, 41 is clearly 40 plus 1, 4 into 10 plus 1. Now, go back to the pattern of 3. So, 3 power n repeated like 3, 9, 7, 1. So, this is for 4k plus 1, 4k plus 2, 4k plus 3, and 4k. So, 41 is of this form. So, this will be 3 itself. Okay. Now, what will be the unit digit of 2 power 34 into 3 power 41? It will be the same as unit digit of 4 into 3. That should be 2. Is that clear? Is this clear? I hope it is, right? Like I try to explain it in a very elaborate way. To understand it more, you have to do more problems. I'll also add the assignment, so don't worry about anything. Now, okay, we'll do some questions as well, and then we'll look at something totally different. A few questions. Now, what is this? 7 power 7777. We simply again have to look at the pattern for 7. What is the pattern for 7? Okay, I have to use some other color. So 7 power n. For n equal to 4k plus 1, 4k plus 2, 4k plus 3, 4. It is 7, 9, 3, 1. right? That's the pattern. So for 7, so we just have to find out what is 7. So we just need to find out what is 7777 mod 4. I'll give you 5 seconds to do that while I erase this and change the color of my pen. You can pause the video and do it as well. Now, for any number, what is the divisibility of 4? We just have to look at the last 2 digits. So 72 is divisible by 4. So of course 76 is divisible by 4. So 77 is simply 4k plus 1. So even if you put 4 sevens or any number of sevens, it will be 4k plus 1. So 4k plus 1 is this. So unit digit of 777 is simply 7. Is that clear? Is that clear? It's very easy. Understood? That's how you approach. I mean, whatever the power be, you again just take mod 4 and check where does the number fit in. Voila, right? Okay. Now this one, this is again simple. Yeah, I'm giving you time to do. So what is 3 power 1999? What is 1999 mod 4? What is 2000 mod 4? What is 2001 mod 4? I mean, if you know 1, you know the rest of the 3. Yeah, so this is 3, this is 0, this is okay. So this implies 3 power 1999 ka unit digit will be. So what is it for 3? What is it for 2? What is it for 7? Let's write down again and again. So 3, 9, 7, 1, 2, 4, 6, 8, 7, 9, 3, 1. So we simply have unit digit of 1999 is for 3 is 3 mod. So we choose this for that. 7. This implies unit digit of 3 power 2000. 2 power 2000. 2 power 2000 is 2000 is mod 4, right? 0 mod 4, 0 mod 4. So we are practically using this 8 and unit digit of 1 mod 4, 7, 37. So this is 37. Okay, unit digit of 37 power 2001 will be the same as unit digit of 7 power 2000. So you just need to look at the last digit power whatever is given, right? So unit digit of 7 power 2001. Easy. 2001 is okay. I added more 0. So that will be 7 itself again. So it is, this number is essentially 7 plus 8 times 7. That happens to be 5, I think. right? Good question. Very good question. Okay. So the next question is a little bit different. So think about it. We did last digit, right? Unit digit. Unit digit implies you are essentially doing 2 power n mod 10, isn't it? For 2 power n, I mean anything. Unit digit of 2 power n congruent to 2 power n mod 10, isn't it? Unit digit of anything is simply the number mod 10, right? The positive number. So I can replace the 2 power n with anything of n is n mod 10, right? Similarly, if I am taking the last two digits, why mod 10? I mean, I hope this is clear, right? Because every n can be written as 10a plus b, where this b will be the unit digit. And this a need not be a single digit, it can be the rest of the numbers. Right? So, okay. So that's what I mean. I hope that is clear. So, what about the last two digits? Last two digits, we should take, let's say I am taking L of n, L2 of n, right, for last two digits. That is congruent to n mod 100, isn't it? Because the last two digits are, mod 100, like that should be obvious. So let's look at a question which deals with last two digits of this product: 101, 102, 103, 197, 198, 199. Come on, do it. Take your time, pause the video and try it for yourself. Okay. So we just need to take this product mod 100, right? The moment we know that, now we know that all these numbers are very close to, each of these number is close to a number 100, right? A multiple of 100. So I can write everything as 101, 102, 103, 193, 197, sorry, 198, 199. This is congruent to 1 mod 100. This is congruent to 2 mod 100. 3 mod 100. Now look at 197, 198, 199. Aren't they just a few numbers less than 200? So I can write this as congruent to minus 3 mod 100. This is congruent to minus 2 mod 100. This is congruent to minus 1 mod 100. Right? That should imply that my 101 into 102 into 103 into 197 into 198 into 199 is congruent to 1 into 2 into 3 into minus 3 into minus 2 into mod, isn't it? right? Okay, so that's simply congruent to 6 into minus 6 minus 36 mod 100, which is congruent to minus 36, meaning plus 64, right? Am I right? Yeah. Yeah, 63 plus 36 plus 64 is 100, right? Mod. So, last two digits of that number is 64. Is that clear? Is that clear? I mean, I hope I made this clear, like what we need. This is here. Last two digits of this is 64. Understood? So, that should be the end of this video, but I will tell you a few things regarding last two digits. That should be here. Yeah. A note on last two digits. A few pointers. Make notes of this. Whoa, something went wrong. Just a minute. Okay. Now 5 power, oh. Five power n. The last two digits will always be 25. Now you should take this as homework. I am telling you. Take this as homework. Take it. Okay. Now power of 6. Repeat as follows: 36, 16, 96, 76 and 56. 7 power n. Do as follows: 0, 7, 4, 9, 3, 4, 4, 3, sorry, and 0, 1. This repeats. That is for 7 power n, and then we have something very interesting. Any number ending with 76, right? Any number ending with 76, it will always end with 76. How do you check this? Tell me. And then, you know, one should note that if we have an n digit number, minus 1 till a2 a1, the last two digits of this power m will depend on the last two digits of simply a2 a1 power. Right? Does that make sense? Because similar to how last digit was dependent on you know, the last digit of the number, similarly the last two digits depend on the last two digits. So this is a very interesting point. Yeah, I want this to be noted. And do I have anything else? No, that's it. So take these as homework. Take them as homework and them as and let me know in the comments whether you have done it or not, right? So that's it, guys. That's it for this video. I'll add the homework as usual, and you know, I hope you will do it without fail. Have a good day. Have a good time. Bye.